Today, I am going to talk on denormalizations. So, generally, whenever we study in the school, college, generally we learn about the normalizations, data normalization in the database systems. So, in the normalization, generally, our objective is that we have to keep whatever the customer's data record as possible as unique value. If the particular data is written in multiple places, so generally we create the separate tables and put the data in the separate tables and refer by the another tables. So overall, the college and life, we always prefer learns about the data normalization. That means we are going to store data in the different places so that they are going to use as the required. So objective is that we are not going to put same data in the same multiple times. Let's example like employee tables. Generally, employee tables will be if you put all the information like employee name, address, city, country, everything. So notice the all the cities same duplicates of duplicate. Maybe country all the same. So notice the employee name, employee age, maybe different employee name, employee age different. But notice the city name and might be country name is the duplicating many times. So preferences, hey, let's create a separate table for the country, separate table for the city, and this use here, this use here. So that was the basic understanding about our normalization. But nowadays, whenever you are going to handle high volume of data, so this normalization techniques is work fit for some level of volumes of data. Some nature of the business where the normalization is very high performance. Let's see here. The benefit is that we can write very optimized query because we can need to join this table, this table, this table. So for smaller data sets, this is joining between the different tables very optimal solution. But whenever we are designing systems where our data volume is going to large and large, so the joining between the tables and that table contain the huge volumes of data that's hit our performance. So due to the performance point of view, we have also learned about the denormalization. So somehow we have to putting data in the same table so that our fetch getting data is without joinings and get the fast retrieval. So some places nowadays in a lots of domains where our system nowadays are handling high volume of data and traffic, and those scenario we have to learn the new concept about the denormalizations, just opposite of the normalizations. So you can say normalization is also good concept. Denormalization is also good concept. Both have a different use case and scenario. Might be in one system we have to use some places is the normalization database, some places is the denormalization as well as. So you can say these are both tools we have and we can use them, right? So let's talk little bit about the denormalization. So you should familiar and about. So the objective of the today's sessions to understand whatever the data we have, how we can uh, make data normalized. Normalization means whatever the data related, which later customers are asking for the get query. Objective of the data denormalization is get improvement in my performance of the system. Means what do you mean by performance of the system? If some customer asks, I need this data, and this data are scattered in multiple tables, multiple file. This is the processing time take to response. That will our performance is little bit delay. So what the denormalization concept say? hey, what are the related data which generally customers asking. So let's put together, okay, so that key our get queries or our application responsiveness is going to as low as possible. So here the denormalization say put data related in the same object, same table, same block, so that the later part when someone going to the get data demand, at that time you can just read the one block and return this. So this is the objectives of our data denormalizations. So as per the theoretical definitions, okay, denormalization. So denormalization is just a process of intentionally designs a database to store redundant data. Notice the objective of normalizations are avoid the duplicate data. But here the same data I am putting multiple places, multiple row, which can improve the read performance. The overall our objective of denormalizations, we can improve my system read performance and the reduce the number of joins and simplified the query. So here denormalizations also help us. There is a no need to joining multiple tables. This is also make our query is very simple. If you notice sometimes your data is very highly normalized and you want to fetch some uh, data from the multiple table, so lots of complex query we have to write. So this denormalizations help us to improve the system read performance and also help developer to avoid unnecessary kind of writing very complex the SQL joining query. And look like in the normalization database, data is organized to minimize the data redundancy and improve the data integrity. So here the normalization have a objective is to minimize to redundant as minimum possible to redundancy. Here, normalization says we are designing the system where we are intentionally going to put the redundant data so that we can improve our data read performance. But this can, whenever we are making data in the multiple table, multiple file, the only performance about the our query so slow performance if your table data is going to the increase. So here we have to write some complex query as well. So the denormalizations help to unnecessary joining, simple query, and overall improve the system read performance in the scenario where we are going to need handle high volume of data. For the smallest data set, the joining normalization is very good. But the nature of applications, these are two tools. Okay, normalization is one tool and denormalization is one techniques we have. Depend upon the use, depend upon the situation, we can use our techniques. So as a basics again, why need denormalizations? Again, improve the read performance. This is the basic criteria. Why you are going to denormalize your data means ki same data you are going to the put multiple places. You are going to storing redundant data, unnecessary wastage of time. But the compare the things what we get by storing redundant data, what the benefit we are getting, we are getting our system performance going to increase, and that is the reduce the unnecessary number of joining indexes which can generally very slow our system. Second, the performance, we are going to reduce the joinings clear. And third benefit we get, our developer are writing very simple queries. You not require so data but expert person, they are going to writing lots of good optimized query. Here the any simple basic understanding of SQL is also able to write data from the denormalized data tables. So denormalization make a very simplest query that is also more efficient. And overall objectives of the denormalization is that increase our system scalabilities. Why need to scale? Because our system are receiving high volume of data. Due to the normalizations, we are putting the simple one table, yeah, one database. That's a very tough to scale our system. So if we are putting data in a redundant format, same data in the multiple place, multiple databases. So denormalization help us to reduce, to help us to distribute data more evenly across the node in the distributed database. That's improve our scalability. So these are the two major point: improve the rate performance and increase the scalability. So these are the benefits, are the reasons why we are going to decide data denormalizations. So during the denormalization process, we have to think the data duplications, data aggregations, and data transformations. These are the techniques. Generally, while the denormalization, you are going to store the same data in the multiple tables. This is the basic rule. Because why? In the later part, we are going to improve the rate performance. Sometimes you also identified storing some pre-aggregated data. So you know this specific request come from the customer that always require to some calculated data. So the denormalization process say, hey, let's just go and store the pre-aggregated data so that at the run times we are not going to aggregate, something complex query. So here we are going to store data duplicate, and the same time we are also going to store data some pre-calculated data, so that whenever customer asks get query, quickly we return the response. We are not going the process of data aggregation at the time of read request come. And sometimes we are also need to transforming data in a more query friendly format. That means first we have to analyze system what kind of commonly uh, get requests come for my data. So all those transformations of data in the different format, each and everything pre-calculated and stored, so that our fetch data is read of my data is as fast as possible. So these are the things generally. While the denormalization process, we have to think we are going to store data, same data in multiple place. Again, some data which require the aggregation. So let's aggregate and put while in the separate table, and some data required kind of data transformations for the user. Yeah, commonly friendly, frequently asked query. So those data transfer and other store. So same data we are storing in the different format, duplicate and different way as well as. And overall, the techniques to things of the denormalization is the your pre-joining, pre-aggregation, cache table, and materialized view. So these are the simple, you can say, techniques where you can think of storing data in a single table to eliminate the need of joining. Simple. Many times you want to just think, hey, I don't want to joining, just data is stored in a simple table, simple file, simple database, and storing data as possible pre-aggregated. Whenever data receive, I know, let's say I want to calculate the every day, yeah, every month, yeah, every hour, our call success ratio, call fail ratio, error ratio. So whenever data come in my system, at the same time we are going to run my aggregator service. Aggregator service is responsible to aggregate data and store. So that the later part, if anyone say, hey, in this hour, what is the number of our call success ratio or call fail ratio, we can properly respond the ticket. And even sometime you notice to objective of denormalization to improve my data rate performance. So caching is also very important. Here we can use the some caching table kind, which are frequently data access read by the request to read. So those are put in the cache table, and we can also create some materialized view. So pre-calculated results of query you can just store, so that key whenever request come, we just get our pre-calculated pre-computed result for the customers. So as we discussed, this is the scenario where you have to think when to denormalize. That means whenever your application receiving high traffic, so here for those scenario, our objective to improve our system performance even in the high traffic scenario. So where denormalized data help us to meet those, handle those high traffic user requests. Even to avoid some complex query, so you can say denormalization can simplify the complex query and improve the rate performance. And generally, all the real-time analytics also required kind of a denormalization help us to improve the real-time analytics system, because in the real times generally lots of dashboard, lots of chart, lots of graph, lots of analytics system analytics are apply some search query. So we know these are the search query generally our search analytic teams are looking. So those query are pre-calculated, aggregated, are stored, just go and return the data as quickly. They are the decentralized system, distributed system, so nearest the customer center cache data even we are put. So due to the nearest to the user request, caching mechanism and pre-calculated query data are stored in the cache, so that we can handle high traffic's request on my system to maintain our system performance as well as. So while the denormalization, we have to also think some consideration and challenges as well as maybe like data consistency problem, data maintenance, and storage requirement. Because you are going to store redundant data, pre-calculated data, some transformed data. So you have to be carefully think your storage requirement, because the denormalized data required high storage capacity. Accordingly, you have to design systems and please recalculate. Hey, if my systems are storing nowadays X amount of data per day, then what would be the monthly storage required, what would be the yearly storage required. Let's we are going to support system for lots 10 year or 50 year, then in 10 year 50 year how much storage we require. So we have to pre-calculate and be clear designs our system. And also here, while the denormalizations, also we have to think how apply the data maintenance. And this is the majorly you can say problem or the challenges in the denormalization system is about the data consistency, because you are storing same data in the multiple places. Okay, so let us example. Hey, we have a system 1, system 2, system 3 distribute the same data you are putting here, putting here, putting here. Okay, and somehow this is the maybe dozens of nodes, and you are someone going to update those data, and so this data is updated in a particular nodes, and later part you are going to sync this updated value in across the your nodes. So while syncing, if some customers are trying to get data from this data center or from this data center, from this data center, at that times customer get some inconsistent data. So please be plan proper data consistency mechanism, so that we can also take care those challenges. So whatever the system you are, what are the tools or technique you are going to apply your system, please be aware. Hey, these kind of because as a system design engineer, our responsibility, we have to give the very holistic overview of the system. We know each and every part where plus point, where is negating point, what is the bottleneck, where in future we can get the problems. And even there are some other kind of consideration, maybe data integrity. So because Major plus point of your normalized systems about they are maintain data integrity because the data are not more redundant. Only one place. If the only one place data change, they are referred by the same table. So always the data consistent data customer get. But here we have to please plans properly data integrities and because you are going to store data in the multiple table, multiple file, multiple database. So please plan the scalability is key. What the problem come in the scalability as well as, and the major things about the data retrieval as well as. So these are things while they're storing data, your storage capacity, data consistency, data integrity issue, and while data retrievals, we have to plan how we are going to data retrieve from the different data centers. So for these good things, all the whatever the database or storage systems we are going to decide for my application, almost everyone provide this facility. Hey, there is no any hard restrictions. Hey, you cannot use the normalization technique or you cannot use the denormalization technique. Every relational database, a non-relational database is designed such a way this is not enforce you. Hey, this is the relational database. That means we always follow the normalization principle. This is the choice of the system design engineer. So most all the database support denormalization. Maybe MySQL, Postgres, MongoDB, anything. Even all the NoSQL database generally especially talk about the maybe MongoDB or Cassandra or Ariaka, all are the designs as a denormalization concept. So almost all the NoSQL database is the basic concept to designs about the denormalization concepts. They are storing redundant data, multiple copy, multiple places, multiple server. So this is a basic concept of the NoSQL databases. But initially, when DB was a database management system started all the relational database, the initial thoughts objective is that we are maintain the data integrity so that we have to ensure proper data normalize and we are avoid as possible data redundancy. But here no SQL just opposite. But now the nature of the business, the way we are going to handle data, we have to think properly data normalization. If our system, we are going to think we are going to decide the data denormalization procedure, so let's select the NoSQL database because NoSQL database is the designs in the keep point of view as a denormalization process. And whatever the data warehouse tools we have available, Amazon have a, Google have a support to because you are going to storing redundant data. That means your volume of data is going to increase. So for those, we need some data warehouse tool. So we should aware after 5 year, after 10 year, if your data volume is so large, so how maintain in the data sensor. So what are the data warehousing tools we have? So because we have to analyze query, we have to run lots of batch query, lots of processes we have to run. So we should plan and lots of for the if your data volume is going too high, so we have to also aware some ETL tool extract and uh, extract load and transform data. So there's lots of tools in the market available, Apache, Nifi, Tenant, or they are lots of tools available for the ETL side, dataware size, and NoSQL side. So these are the technology already designs for the denormalization techniques. And these are the some lots of you can say applications are the examples where the Amazon use the denormalization concept to improve the our system performance of the whatever the e-commerce platform Amazon has. So almost all the big player nowadays who are handling high traffics of user requests, generally they are using the concept of the data denormalization to improve the system performance. You talk about the Google, you talk about the Facebook, Twitter, and lots of big, you can say, applications which generally nowadays we are using. Internally, they are using the denormalization process, as well as this is the applications. Whenever the bigger applications, they are not intended to design only one kind of a technique like a normalization or denormalization. We can also keep only the denormalization database are used by the Amazon or Google or Facebook. They have a combination of database. So some portions of module of the function where the data denormalization required. So these are the tools, the techniques, the technologies we have available. So we as a system design engineer, we should aware, hey, we have options, this module, this functions where the we are want to real time analytics, real time responses. So where we have to apply the denormalization process or concept as. So for this scenario, whenever you are going to denormalization, we have to follow some best practices that help us to properly make our system denormalize, and we can use the uh, proper tools and techniques. So best things to deciding I'm going to denormalize. First, we have to measure your performance as well as. So measure the performance before and after. Hey, if you're not getting any kind of benefits, you have to lots of cost we have to be that's not make a sense. So we have to also time to times monitors your performance before the denormalization and after denormalization. And if you get drastically benefits your system performance, let's go, because we have to bear the cost as well as. And also we have to identify properly bottlenecks of the system, identify the performance bottlenecks, and then, hey, this is a bottleneck here, we surely now need to the normalization process, a denormalization process. And sometime you can use indexing or caching your data, monitoring consistency tools, or use the transactional, because the here in the denormalization concept, uh, we have to ensure the data integrity. So for the data integrity, we have to properly use the transactions technique to ensure that data consistency and data integrity can maintain in the denormalized data as well as. So lots of transactional utility transaction technique have one page commits, two page copies, other transaction, lots of techniques and a process available where you can manage data integrity and data consistency for your denormalized data as well as. So this is the kind of channel thoughts. You can say denormalizations is also kind of a good techniques we have and for to improving my system performance. So denormalization, the major the idea where we are going to use the denormalization to improve my system performance and to handle high volume of data. Okay. And if by applying the proper techniques and best practices, surely denormalization help us to improve my system performance. Okay. So, but please be carefully. We have to plans uh, whenever we are planning data denormalizations. So you have to ensure that properly plan considerations about the data consistency and integrity. Lots of techniques, methodology already exist in the market, technology exists in the market, where in the denormalized data, you can apply data consistency and the integrity. Because some business, you cannot compromise the data integrity. So these are some basic points. You as a system design engineer, your responsibility, you should aware, hey, data we can store in the normalized format, or data we can store in the denormalization technique as well as. And both techniques are the different use cases. Both techniques are used in application. So all the bigger applications, whatever the systems you're designing, many times you can say we are going to use the both technique, normalization technique as well as the denormalization technique. But a smaller application, limited use case application, your normalized data is sufficient to meet the customer requirement. So The techniques, normalization technique or denormalization techniques, are used, are you decided on the basis of your use cases, your customer requirement. Many places only denormalization data techniques are good. Some cases normalized data techniques are good. Some use cases, some application, you required both. So many places nowadays we require the both, because the whatever the bigger application where the some places data integrity or data consistency is very required, where we can go the normalization process. Somewhere some compromise happen, go to the data denormalization process, because finally we have a plus and minus for the both. Hope this information helpful for you.